Distribute and combine like terms. We're going to distribute the negative 4/5 x. Negative 4 times negative 2 is positive 8/5. And then we are adding 8. These two are like terms. It might be helpful to change 8/5 into a mixed number. 5 goes into 8 one time with 3/5 left over. And then we can add 8 to that. I'll have negative 4/5 x plus the 8 and the 1 together make 9 and 3/5. In class, we'll be doing the take a stand routine, and there will be 4 different signs on the wall, and you'll have to decide which equation or whether an equation matches with this line. The first possibility is y equals negative 1/2 x plus 4. Remember, in slope-intercept form, this value tells us where to start on the y-axis, and this is the slope. So that would be down 1 and over 2, which does follow the directions on the line. So this one is a correct equation. The next one that shows up is the equation y minus 3 equals negative 1/2 x minus 2, which appears to be in point slope form. The slope is negative 1/2. We're going down 1 and over 2. And in point slope form, the x value would be 2 and the y value would be 3, which is this point here. So that is also an equation that works for this. And you can see if we distributed and moved 3 over, it would look something like this. Negative 1/2 times negative 2 is positive 1. Then we would add the 3 to the both sides. And we would find the slope-intercept version of the equation that we just had. This last equation is written in what's called standard form, but if we converted it to slope-intercept form, we would then divide by 2 to solve it for y. So that piece comes out to negative 1/2 x, and 8 divided by 2 is 4, which again is that slope-intercept version of the line. So all 3 of the equations presented work for this line, they're just written in different formats. For problems 1 through 3, graph the equation. So on a slope-intercept form, when it's written in y equals mx plus b format, we start at the b value on the y-axis, and then we use the slope to graph the next point. So it's going to say down 1, right 2. Down 1, right 2. We always move to the right, and then whether our slope is positive or negative tells us if we move up or down. And so then we will graph the line by using a straight edge that goes through the points. This next one is written in point slope form. So the slope is still negative 1/2, but it's going to go through the point 2, 3. And we'll go down 1, right 2. And then connect them using a straight edge. For this one, usually in standard form, we'll use what's called the zeros of a line. So we'll plug in 0 for x and solve it for y. Divide both sides by 2, and we'd end up with y equals 4. Then we'll do the same thing, but this time replacing the y value with 0. So x has to equal 8. Then we can graph both of those points. 8, 0 would be here, and 0, 4 would be here. And then we'll connect those using a straight edge. So we saw that all three of those equations worked to graph the same line. We had this point as our y-intercept. We had the 2, 3 as one of the points in the point slope form. We also had 8, 0, and 0, 4 as our zeros of the graph when written in standard form. 4 says write the equations from problems 2 and 3 in slope-intercept form. So this is where we're going to change them. We'll start this one by distributing. Half of negative 1/2 times negative 2 is positive 1. Again, we'll move 3 over. For this one, we're going to move the x to the other side so that the y's are by themselves. And then divide both sides by 2 so we have y by itself. And 8 divided by 2 is 4. For problems 5 through 8, write the given equation in slope-intercept form. So we're solving it for y. So we'll move the 5x to the other side. The x and the numbers can't be combined, so you have to just write it next to it. For number 6, we'll need to start by distributing. Negative 4 times negative 2 is positive 8. And we'll subtract 8 from both sides. And y equals negative 4x. For this one, we'll start by moving the 3x over, so we have y's on the left. The 3x and the negative 12 cannot be combined because they are not like terms. Then we'll divide both sides by 4. Negative 3 divided by 4 is negative 3/4. Negative 12 divided by 4 is negative 3. For this one, we'll require the distributive property. Seven times 1/4 is 7/4. Then we'll subtract 1 to move it over and leave us with y on the left. Subtracting 1 is the same as subtracting 4/4. So negative 7 and negative 4/4 is negative 11/4. Consider the lines L and N represented by the tables. Write an equation for each line. I'm going to write them in slope-intercept form. So we need to figure out, well, y2 minus y1, or what's the difference here? 14 minus 8 is a difference of 6. Negative 9 minus 0 is a difference of negative 9. So then the slope here would be 6 over negative 9, which reduces to negative 2/3. And then our b value, that's where it crosses the y-axis. So this one has the point 0.08, that is the y-intercept. So I can add 8. Over here, negative 2 minus negative 6 would be positive 4. And this one, 15 minus 21, is negative 6. So the slope here is 4 over negative 6, which is also negative 2/3. But I don't have a 0 to place b yet. What I can do is use point slope form, or I can plug in a point and solve it for b. So I'm going to plug in a point. I'm going to place 15 in the x value and negative 2 in the y position. Two times 15 is 30. 30 divided by 3 is 10, so this is negative 10. Add 10 to both sides. And I end up with b equals 8. Are lines L and N the same line? Explain how you know. Well, yes, they have the same slope and the same y-intercept. Consider L, N, and P represented by the tables. Are these lines the same? Explain. Which lines are parallel? Explain. So we're going to start by finding the difference between these. 11 minus 2 is 9. 7 minus 4 is 3. So that would be a slope of 9/3, which is equal to 3. 18 minus 6 is 12. 9 minus 5 is 4. 12 divided by 4 is also 3. Nine minus negative 15 would be positive 24. 6 minus negative 2 is positive 8. 24 divided by 8 is also 3. So which lines are parallel? They all have the same slope, so they all have the potential to be parallel. The only thing that would change whether they were parallel or the same line is if they have the same y-intercepts. So let's figure out what their y-intercepts are. I'm going to use a point from the table. So in that format, y equals mx plus b. All of them have a slope of 3. And I'm going to replace the y value with a 2 and the x value with a 4. 3 times 4 is 12. If I subtract 12 from both sides, that leaves me with b, and 2 minus 12 is negative 10. Now we're going to follow that same type of process for the next table. The y value is 6, the slope is 3, the x value is 5, and we're solving it for b. 3 times 5 is 15. To solve for b, I need to subtract 15 from both sides. That leaves me with b over here on the right. 6 minus 15 is negative 9. And then also pick a point from this table. I'm using ones where they're positive just to eliminate the need for negative values. The y value is 9, the slope is 3, the x value is 6, and we're solving for b. 3 times 6 is 18. To solve it for b, I need to move the 18 over to the other side. That leaves me with b. 9 minus 18 is negative 9. So down here, we need to state which ones are the same. Are all lines the same? Well, no. Only lines N and P are the same. Since they have the same slope and the same y-intercept. Which lines are parallel? Well, in order to be parallel, they need the same slope, but different y-intercepts. So, oops, they all have the same slope, but the ones that have different y-intercepts would be line L and N are parallel. And L is parallel to P. That's the end of lesson 23. Check back for future lessons coming soon.